Hello friends, I hope you are doing well. Here I come back with another video. On today's video, I'm going to show you about shift registers. Basically, I will focus on left and right shift registers. So I will make many videos on the practical application of shift registers like container tracking. Okay, so if you are new to my channel, please subscribe, share and like my videos. Thank you. To show you the basic, then I will go to the practical application. So as you see on the screen, the shift registers, as you see on the diagram, the bits are shifted left, as you see on the those read arrows. Okay, so it's replaced by 0, then go to the next shift, and likewise so right shift registers, so the bits are shifted to the right, as you see. So the 1 is replaced by the 0. This one, every time it shifts, the value will be replaced by 0. So this shows this one. So it works like this. So let's do one practical one on the semantic manager, so it will be clear. So let's prove this one on our semantic manager. Okay, I have already created the semantic manager. Let's insert our PLC. The rack first. Okay, let's insert the CPU. Let's change the IP 10 and create a new network. Okay, so and then for the hardware, for this PLC I have done. Great. Let's also let's open this. I want to configure the HMI also. I see some comments to do the WinCC also. So let's create new project on the WinCC. Opening. Okay, let's create new project again for this one. My PC panel, this one. Let's save this one. Okay, sorry. It's opening. Let's save. Project name shift registers, PLC shift registers. Okay, great. Let's go and integrate with our PLC, our Siemens PLC. My project is PLC shift register. So this one, it's integrated. So let's see on our semantic. So it's automatically here on our Siemens. Okay, so we have to edit one thing here on the hardware configuration. We have to configure the IP for the HMI. Okay, here HMI. and this one I have to add. So let's say 10.100 on the existing network. Okay, then save and compile. Great, I'm done the integration, and so let's see the connection now on the WinCC. Great, the HMI is 10.100 and the PLC is 10.10. Great, let's save this. So we are almost configured correctly for the integration of this WinCC with the schematic manager. So now let's do the program again. Let's do on the OB1. Okay, let's say we have a sensor that detects the bottle or a container, feed container. Detector 1. So this will parameterize our shift register. That means it will detect the presence of a bottle or any container. Let's put here on the positive trigger, and here we will set. Okay, so let's say input 1.1 and M 1.3. Let's say this one M 103.0. Okay, this is the bottle detector 1. Bottle detect 1. Great. Let's add one network again. Shift. Okay, then let's put here again 1 and put the trigger again. This one is a shift left, that's M1.0. M.1. Okay, sorry. The shifting trigger will be this one, M1.0. So this means shift left. Trigger. Great. So let's put the left shift register around here, shift. So I'm going to use the double, shift left double, because I want 32 bits. Okay, shift by 1, and the shifting will be M101 MD100. This is the shift register data, left shift register data. Let's say this one, left shift register value. Left shift register value. Okay, this is double volt. Thank you. So I'm done for the left shift. So here this will be parameterized my MBD 100 the last byte. I think I have made a video how the data are stored when we transfer to a word and a double word, and so I'm going to initialize my MD100, the first bit. That's the first bit, means 103.0. So it will be active the first bit, then shift later by this. Okay, I'm done for the left, so let's do for the right. Again, I will put here the feed sensor container detector 2. This is for the right shift, so it's the same. Okay, trigger positive and set. So this one is my sensor input 1 input 2.0. Let's make this one M.3, and this one I'm going to use the MD200. So I'm going to activate the last bit of MD 200, so that means MD M200.7 means the last bit. Okay, this will be clear when we are simulating later. So this one is the container detector 2. Okay, let's add one network for the shifting right. Shift right. So here again I will do the positive trigger and shift right double, this one. So this is the shift right trigger, right trigger. Okay, this MD200 is my data for the shift right. So the data going to shifted on the right will be 200, MD200. So let's say this is shift right shift register, shift register value. Okay, double word here also. Okay, and the data will be shifted by only one bit. You can make it 2 or 3 as you want, but I'm going to use 1, so the bits will be shifted by 1 only. Okay, I'm done the program on the Siemens. As you see, this is for left shift, and the last two networks are for the right. Okay, we have done the Siemens, the program on the Siemens manager, schematic manager. Let's do on the WinCC. So let's insert our objective here. Let's say this one. Left shift register. Okay. Layout is auto. Text, let's make it bold. The color, let's make it blue. Okay, let's insert some input field, the output field. This one, output. Okay, I have to create the tags first before adding the object. Let's create some tags. Left shift register shift regi value. Okay, connection is connection one. Okay, this is double word. You have to use memory 100. Okay, here right shift data value. The address, this is going to be 200. Let's do the same with the left shift trigger. This one bool and this one 1. Okay, right shift trigger. The address, this one to must be the same with the Siemens tag. Yeah, this one's the shift left trigger M 1.0 and right shift trigger M 2.0. Okay, and these are the tags that I'm creating now. Okay, let's save this one. So let's now edit this one. This one layout must be auto sized and color. This is going to be output. This one a bool binary, and this M100, and it is a double, so 32 bits. Insert one button to shift the shift register. Shift left. Okay, layout must be auto sized, and the text make it bold. Okay, center. Color, let's blue again. This one. The text size is a little small. Let's make it 12. Okay. Let's add one graphical image that clearly shows how the bits are shifted to the left. So let's add that on our WinCC. Okay. Okay. As you see on the image, the bits are shifted to the left, and the first bit every time replaced by 0. Okay. So let's parameterize our button. When it is pressed, it must set the shift right trigger bit. And when it is released, it must reset again. Reset. Reset left button. Okay. And our shift register is going to be MD100. We can see on the Siemens program that here are the this is we linked our button with M1.0. That is the shift left trigger. So when this trigger is activated, the shift register shifts one time to the left. Okay, let's save this one. We have done for the shift left register. Let's add for our shift right shift register. Copy, paste. Let's copy and paste this one to save time. Right. Sorry, I have duplicated the copy paste, so let me remove one by one. This is going to be shift right. So let's parameterize. This will be set the shift right trigger, that's M 2.0, and this means when released it must reset that bit again, that bit, this one. And let's edit our shift register, MD200. Great. So let's add one image, graphical image that clearly shows the bit movement of right shift register. Okay. So as you see, the image shows clearly how the bits are shifted to the right, and the first bit will be replaced by 0 every time the shift register shifts. Okay, I think I'm done. Let's see the parameter again one time. Let's check. Okay, right shift. Okay, great. So let's save. Done creating the WinCC program. So let's save, and let's load our Siemens program to our CP. And let's open OB1 monitor, and let's start our WinCC runtime. Great. Okay. So as you see, when I click shift left, nothing is happening on our shift register because the shift register is now empty. So we can't visualize the movement of the bits because each bits are zero. So let's parameterize our shift register shift. So as you see on the program, there is a bottle detector that feeds to the filling machine. So let's say I have a filling machine. So this bottle present or the bottle detector will detect the feeded bottles. So every time the bottle feeded, the shift register will be parameterized. So let's feed bottle. So as you see, the shift register parameterized. Then when we click shift left, the bits are moving to left, as you see. So let's add another bottle. As you see, the shift register parameterized, and when we click shift left, the bits are shifting to the left, and the last bit, the first bit will be replaced by zero, as you see. So uh, this is how the PLC knows the position of each bottles that are fed to the filling machine. In practical, this is very important because you can detect a fault, a defective bottles or other type of bottles. Then you can reject those bottles. Okay, let's feed another bottle. As you see, the shift register parameterized shift left. This button is in actual, in practical, the shift, this button will be connect or integrate with the encoder. Every time the machine rotates, this shift register shifts the bits to the left or to the outlet. Okay, L- let's do the same for the right shift. Again, the right shift is now empty. Shift register is empty, so we can't visualize. Let's parameterize. So this one is the program again for the right. So let's feed a bottle to the filling machine too. This means this one input 2.0 is a bottle detector or container detector. So let's feed one bottle. As you see, the shift register parameterized. So let's click shift right. The bits are shifting to the right. So let's feed another bottle again. As you see, the shift register updated and the shift to the left. And let's add another bottle. As you see, the shift register again parameterized and the shifting to the right. So as you see, the program works correctly, and as it's, it works correctly. So in today's video, I'm showing you how the shift registers work, only the introduction part. But this shift register has many practical applications, so I will do a video on those practical applications like tracking of a both position and detecting the faulty, rejecting that one. So I will do such related videos on my next video. On today's video, I'm done. If you have a question, you can put in the comment section. And also, if you are new to my channel, please subscribe and share, like my videos. Uh, I'm Thank you for watching me. See you on my next video. Thank you.